Hello everyone and welcome back to Up 360 Circuits, your go-to channel for electronics tutorials, embedded systems and practical IoT projects. In today's project, we will be exploring the SNO4N Inductive Proximity Sensor, also known as a metal detector sensor, a popular industrial sensor used for metal detection and non-contact object sensing. So we'll be using the Arduino Uno, the SNO4 proximity sensor, also known as the metal detector sensor, some resistors. The SNO4N sensor is capable of detecting metallic objects without requiring physical contact, although those objects can also be detected if they make physical contact with the sensor, making it useful in automation systems, conveyor systems, object counting applications, and smart manufacturing environments. In this video, we will examine the sensor's operating principle, explain the connections, perform a live detection test, and discuss its advantages and limitations. Let us begin with a brief overview of the SNO4N sensor. The sensor is an inductive proximity sensor designed specifically for detecting metal objects. It operates using electromagnetic induction. When a metal object enters the sensor's detection field, the sensor changes its output state and signals the presence of the metallic object. So it is able to detect metal objects within the distance of 0 to 4 millimeters, which means that if you place the metal object directly on the sensor, it will detect it, and if you place it within distances between 0 to 4 millimeters, they would also be detected. Some key features include non-contact metal detection, fast response time, industrial grade reliability, resistance to dust and dirt, long operational lifespan. The sensor is commonly used in industrial automation systems where reliable metal detection is required. So the sensor operates by generating an electromagnetic field at its sensing face. So when a metallic object enters this field, the electromagnetic characteristics changes, and the sensor detects this change and activates its output signal. The sensor also contains a red LED which turns on, that is high, when a metal is detected. Also, one important point to remember is that the sensor is designed specifically for metallic objects, so the sensor can only detect metals. Materials such as plastic, wood, or not be detected. Alright, so I would be showing you how the sensor is connected. But first, the sensor contains 3 wires: the brown wire for VCC, the blue for ground, and the black for output. Also, the sensor uses a 12-volt adapter because it can only be powered with voltages between 6 volts to 36 volts. So we're using a 12-volt adapter. We would also be needing voltage dividers, so we're using a resistor for that, because since the sensor uses a 12 volt and the Arduino only receives signals between 3.3 and 5 volts, we need to step down the voltage to between 4.8 and 4.9. So I would be using a 6.8 volt resistor and a 4.7 volts. You can use any other resistors that you have that would also give you an output of 4.8. Also, we'll be using a pull-up resistor of 1k ohms. So now we connect. Just connect the positive wire of your adapter to the brown wire of your sensor, just like I have done, and then you connect an extra jumper wire to your VCC, your red and brown wire. just like this. And then to your black output wire, connect two extra jumper wires like this. And for your blue wire, that is the ground, you connect the ground of your adapter and an extra jumper wire. So you place your 6.8 volt resistor like that, and your 4.7 connected together like that. Then get your Arduino Uno and a wire to jump out the ground. So take one of the wires connected to your black, your output, then connect it to the far end of the 6.8 ohms, and take another wire and you connect it to the junction where the 6.8 volts, the 6.8 ohms and the 4.7 ohms meet, like that. And then you connect that to your digital pin using pin 2. That goes in. And then you put your 1k ohms on the breadboard. Yeah. And then connect one wire from your VCC, from the red and brown wire, the one you attached, to one end, and then the other wire from the output, that is the black wire, to the other end. Okay, I'm just going to move the last wire from your ground to your ground, and we can see that the other end of the 4.7 ohms resistor is empty, so you connect an extra wire and jump it to ground. Alright, so I am going to briefly walk you through my code. So first you define your sensor pin, that is digital pin 2, and then under your setup you initialize the serial monitor, serial.begin. Then you set your sensor pin to input, that is, you set the pin mode. And then we move on to the loop. We initialize the sensor state to get digital readings from the sensor pin. And then if the sensor state is low, it serial prints metal detected, else it serial prints no metal. And then you add a little delay. I added 300 for functionality. Alright, so let's test the system live. So I'll just plug in my Arduino. And upload the code. As you can see, the serial monitor initially displays no metal because the sensor is not detecting any metal. So I'm going to be using two different types of metals to test, potentiometer and a plier. So once I move my plier close to the sensor and it detects it, the red light goes on and it says metal detected, just like that. When I move it away, no metal. So I'll use potentiometer 2. As you can see, metal detected, no metal, metal detected. You can also place it directly on the sensor this way, metal detected, no metal. In this project, we successfully explored the SNO4N Inductive proximity sensor, also known as metal detector, and demonstrated its ability to detect metallic objects without physical contact. We were able to understand how inductive sensing works, interface the sensor with an Arduino system, detect metallic objects successfully, verify reliable operations through practical testing, and observe its industrial applications. The metal detector sensor is an excellent sensor for metal detection tasks and remains a popular choice for industrial automation and embedded control systems. If you found this project helpful, don't forget to like, share, and subscribe. For quality electronic components, check out Up 360 Circuits. Thank you for watching, and I'll see you in the next project.